All right, ladies and gentlemen, welcome back to this Athenian Stranger tutorial video. This small video here is a section of a worksheet that is completed in another video, and this section is specifically for pre-AP students who have been asked to find the vertex of a quadratic function by hand in order to graph it. I wanted to make a separate video on this so the timing didn't get eaten up for non-pre-AP students. So in the worksheet that this page is a part of, we discovered by foiling out a factored form quadratic equation that our quadratic function is f of x equals x squared plus 5x minus 14. And we already learned that the initial value here in the a position is 1. That means it's an upward pointing quadratic function. And we learned that the terminal digits here, the c position value, this is a constant term. This represents the y-intercept. And so what we want to do is find the vertex. The vertex would be the bottom of the hoop. If it's an upward pointing quadratic function, that's called a minimum point. Or if it was a downward pointing quadratic function, that would be the top of the hoop, and that would be a maximum. So we want to find the coordinates of that vertex. Now, to find the vertex, we have to find the x and y coordinates individually. We have to find the x coordinate first, and we always have to do that first. To find the x coordinate, we use this little formula right here. This is one to remember. So the formula for the x coordinate of the vertex of a quadratic function is negative b over 2a. So in our example here, we have f of x equals x squared plus 5x minus 14. And the general formula of a quadratic function is ax squared plus bx plus c. So what we do is we kind of match up the letters with their corresponding numbers in our actual function. And we find that the a position value is 1. Since there's nothing sitting in front of the x squared, it's just 1. And the b position value right here corresponds to 5. So b is 5. So now that we know those two letter values, we can plug them into this little formula here, x equals negative b over 2a, and say x equals, and now we're just going to plug in negative 5 over 2 times 1. Okay, make sure you write that down there. So we can simplify this a little bit. We have negative 5 over 2. And as it turns out, we're going to need this improper fraction right here in order to compute the y coordinate of the vertex. But for now, we'll continue and turn this fraction into a decimal. And 2 goes into 5 2 times with 1 as a remainder. That would be 2.5. So it would be negative 2.5 would be the decimal form of negative 5 over 2. So the way this works is, for graphing purposes, when you're actually plotting it on a coordinate plane, you'll need the decimal form. But in order to find the y coordinate, you'll use the improper fraction form of the x coordinate. So let's read on. To find the y coordinate, we evaluate the quadratic function at the x coordinate. So if f of x equals x squared plus 5x minus 14, and x equals, must use improper fractions, so x equals negative 5 over 2, then f of negative 5 over 2, so what I'm doing here is I'm evaluating this quadratic function at the value negative 5 over 2. So what I'm going to do is I'm going to plug in a negative 5 over 2 everywhere I see an x. So if f of negative 5 over 2 equals, and then we'll put negative 5 over 2 here, and that value would be squared in our original function. So we'll put parentheses around it and square it, plus 5, open parentheses, and I'll put in negative 5 over 2, close parentheses, and that constant term minus 14, it just comes in at the end. Nothing to do there. Okay, so that's the setup. Be real careful if you're ever going to do this in a calculator. There's a big difference between negative 5 over 2 squared and open parentheses, negative 5 over 2 close parentheses squared. It's going to give you a different number, the way the TI calculator works. So I prefer to do it by hand anyway, because I tend to forget to do that with the parentheses and I get it wrong. So let's just do it by hand. Now this allows us to use the power property of exponents. When I've got a fraction raised to an exponent, I can distribute that exponent to each the numerator and denominator of the fraction. Let me show you what that looks like. So the next iteration here, we will distribute this exponent. Okay, each of these numbers in the fraction have an exponent of 1. The power property says we multiply those exponents. So I'll have negative 5 squared over 2 squared. Okay, so we'll leave that just like that. And now we're going to put the plus symbol here. And then I have 5 times negative 5 over 2, which would be negative 25 over 2. Minus 14. So this is about to become a situation where we need to find a common denominator, but let's keep working with this. Let's get rid of the squared terms. So we know that when we square a negative number here for negative 5 squared, we know that that's going to be positive. So negative 5 squared is the same thing as 5 squared. It's going to be 25. So in the numerator, I put 25 over 2 squared is 4. And just to focus in on this negative 5 squared, it's negative 5 times negative 5, and that's why we get positive 25. Okay, so 25 over 4, and then I can get rid of this plus minus battle here and say minus. And now it would be advantageous to me to put 25 over 2 in terms of a denominator of 4. So I just need to multiply numerator and denominator by 2 to scale that up. So that would be minus 50 over 2, over 4 rather. Okay. So 25 over 2 scales up to 50 over 4, same thing. And now we need to subtract 14, but we should put 14 in terms of 4. So over in side work here, we'll do 14 times 4. We're basically doing 14 over 1 times 4 over 1, 4 over 4. And 14 times 4 is 56. So rather than writing minus 14, I'll write minus 56 over 4. Okay, so you see now we have common denominators across all 3 terms. So I can rewrite this with all of the numerator terms above a single denominator. 25 minus 50 minus 56 all over 4. Okay, so let's just carefully subtract all this from left to right. 25 minus 50 would be negative 25. And then I'll do negative 25 minus 56, but I'll write those steps out. So it's going to be, first step would be 25 minus 50. Negative 25 would be the result. So I write negative 25 minus 56. Over 4. Okay, so now we have to figure out by hand what negative 25 minus 56 is over in side work here. So that ends up being like an addition problem with negative numbers. So it's negative 25 minus 56. And you set this up like an addition problem. So looks like that, kind of like plus. Just add it up like it was an addition problem. So 5 plus 6 is 11, carry the 1. 2 plus 5 is 7, plus 1 is 8. So negative 25 minus 56 is negative 81. Okay, maybe you're able to do that in your head. I'm not good at doing that in my head, so always do it on side work. So finally here I'll write equals negative 81 over 4. Okay, now I need to, so that's what this is going to become is the y-coordinate of the vertex. I found the x-coordinate, it was negative 5 over 2 or negative 2.5. Now I need to convert this improper fraction y-coordinate of the vertex into a decimal. So we'll just divide 81 by 4 and put a negative sign in front of the quotient. All right, so put on your long division thinking cap here. 4 goes into 8 2 times. 2 times 4 is 8. And 8 minus 8 is 0. Bring down the 1. 4 goes into 1 0 times. 0 times 4 is 0. 1 minus 0 is 1. And now I'll have to put a decimal point and bring down another 0. Like that. So now I'm looking at 10. 4 goes into 10 2 times. 2 times 4 is 8. 10 minus 8 is 2. Bring down another 0. 4 goes into 25 times. And since 5 times 4 is 20, we won't have a remainder. And that will terminate the decimal. So what it means is negative 81 divided by 4 is going to be negative 20.25. Okay? So we'll put a final equals here, negative 20.25. So let's kind of bring it all together here for a minute here. We'll say this, if the x coordinate is negative 2.5 and the y coordinate is negative 20.25, then, I'll move my hand here, then, so if the x-coordinate is negative 2.5 and the y-coordinate is negative 20.25, then the vertex and remember in this case the vertex would be a minimum, so we'll put parentheses minimum. It's an upward sloping hoop the bottom of it would be the vertex, so that'd be the minimum. The vertex is located at negative 2.5, comma, negative 20.25, x comma y. Okay, parentheses. We should also add here something. Whenever you find the x-coordinate of the vertex, you are also finding the axis of symmetry. Let me say that again. The x-coordinate of the vertex is the axis of symmetry. So I'll say, also, the axis of symmetry is a vertical line passing through negative 2.5. Well, I should say vertical dotted or dashed line, vertical dotted line, because it's not like part of the function. The vertical dotted line passing through the vertex. Okay? So, quick little sketch of what you just figured out. You figured out that we have, remember what our x-intercepts were -7 and 2. So if we're just building out a little tiny graph, we have a y-intercept of -14. So if I'm building out a little graph here, this is a little simple sketch, so you guys get an insight of how fast you can draw these. Just estimate it with your eyeballs. So if I'm going to call this 2, right, we'll call this down here, we'll call this will be -20.25. Okay, on the y-axis, and that would be about right here, this would be about -14. That's my y-intercept. Okay, over here, this would be like -7. So that's the other x-intercept. We can already plot a basic quadratic function because this axis of symmetry right here would be -2.5. Okay, so the way you plot these in, you say, well, I know that the axis of symmetry is passing. It's a vertical dotted line passing right through -2.5 on the x. So I'm just going to draw this in like this. This helps guide your drawing a little bit. And now you put on that axis of symmetry at -20.25, you'll put a big dot, and that will be the vertex. Okay, so that you found where to plot the bottom of the curve. And now we'll just sketch in a quadratic passing through all these points here. Remember, I'm going to find this reflected point, just basically reflecting it visually so I know where to sketch. That way I've got a symmetric sketch that I'm going to perform here. And so my quadratic would look something like this. Okay, it's not a perfect picture, but you get the idea. We have all the major points plotted. We have both of our x-intercepts plotted, the y-intercept, and the vertex. Okay, so that's how you find the vertex by hand. They're not usually this hard, but I wanted to show an example where you had to find the vertex when the x value of the vertex was fractional. And that means you always, whenever you have a fractional vertex x-coordinate using a quadratic function, you always have to use the power property in the first position, since the first position value is a squared term. And you have to distribute that too, like you see here. That's the hairy part, evaluating the x value. Also, let's remember that the x value is found by taking negative b over 2a. This needs to be committed to memory. The standard form equation needs to be committed to memory as well. So, okay. Yep, that ran for 20 minutes. That would have put us over our video time by 10 minutes in the class. So I'm glad I recorded this as a separate video. All right, so continue on with the packet. You'll have to do this for every single homework problem, but by every single homework problem, I mean 3. So you have 3 homework problems. None of them will be hard like this because all of them will be integer values at the vertex. So you won't have to square a fraction. But good job. Okay, so if you like this video, give it a thumbs up. If you have a question, leave it in the comment section. And if you have not already, please subscribe to my channel. Put out a lot of good videos here on math. And hit that notification bell so you're always alerted to new videos on this channel. Thanks.